Okay, hey, good afternoon, everyone, and welcome to Climate Governance Malaysia CGM's Roundtable Series 2025. Thank you all for joining us. So before we kick off on the roundtable today, please let me give you a little bit of background as to what the roundtable series is all about. And before that, my name is Jenifer Thien. I'm a council member with Climate Governance Malaysia. So with regards to the roundtable series, and you may have seen this in our communications, this series is designed to be a collaborative platform where industry leaders, academics, corporate individuals, and corporate organizations, industry leaders, policymakers, and so on can come together. And what we want to do is to crowdsource practical policy recommendations for Malaysia's climate transition. Right, so we have done this before, and glad to say that it's been successful in terms of moving this agenda forward. So the series itself, in the coming weeks, we will be hosting 18 roundtables, and this will be covering 6 very broad themes, covering biodiversity, agriculture, energy and resources, transition finance, the built environment, and also community engagement. We are very, very grateful to all our partners and obviously all of the subject matter experts, for leading these discussions. We are also very fortunate that PwC Malaysia is supporting us in terms of capturing the key outputs so that we can translate the ideas and all of the inputs into concrete next steps and actions. So for today, this is the first roundtable of this series, the first of the 18. And today's topic is focused on building verifiable carbon sinks for Malaysia's net zero future. So very, very interesting, very exciting topic. This session is curated and hosted by Wild Asia, and it will be moderated by Wild Asia's founder and director, Dr. Reza Azmi. Wild Asia, very quickly, is established in 2003 and is a social and environmental enterprise dedicated to promoting sustainable natural resource management. And also they do quite a lot of work with local communities as well. So before I hand over to Dr. Reza, just a few quick housekeeping notes. Questions and answers. We plan to have a few of the Q&A session throughout the 1.5 hours that we have. So if you do have questions, please pop them into the Q&A box. And secondly, this is a 90-minute session, as we have shared with you in the earlier information material. So we will plan to have a hard stop at 6 p.m. So with that, I'm going to pass over to Dr. Reza, and he will start the session by giving us an overview of today's discussion, as well as introduce us to the speakers. So Dr. Reza, over to you.
Very good.
Thank you.
Thanks, Jenifer. Yeah, so good afternoon, Reza, Wild Asia. I've crowdsourced a little bit far and wide, beyond Malaysian borders. And we are going to, I framed it as verified carbon sinks, and the verification part was just making sure that we're on the right track, whether certification, whether validation. Carbon sinks is a concept that we're going to hopefully get across. Some people have started to hear about the role of biochar in creating carbon sinks. So we're going to start looking into some of those aspects. I won't go through like each of the speakers in terms of introducing them, but I will have a slide where I'll show you in just 2 seconds. I will show you the lineup of speakers we have, but we'll start with the sort of science and the background to biochar. And then I'll just let the speakers kind of introduce themselves as just before they present. We'll cover then some of the technologies, low tech to high tech, as well as then look at the two different ways in which people are validating some of these projects. And then we'll sort of come to a sort of recap session at the end. So each of the three sections are going to be discrete. In other words, there will be a short Q&A session at the end of each section. So if you have questions, post them in the side note. But before we started, I thought it would be good to just kind of set the scene a little bit. So a couple of things that should give us sleepless nights, and I guess one of them is obviously over the last, since the Industrial Revolution, we've seen this huge increase in global surface temperatures. And then just in the last 10 years, everything's been going off the charts. You're seeing doubling, tripling of rate. So the rate that these things are happening is starting to worry a lot of people. Not everybody. The other thing that you'll notice is that, people predict also that it almost follows the same curve. Economic growth is almost mirroring this rise in global surface temperature. So what we see is that although carbon sinks in the form of natural systems, forests and seas are meant to be able to absorb a lot of this carbon, we're finding that it's not working anymore. Those areas that we were expecting to be these great sink sources are not functioning, because at some point when there's too much carbon dioxide in the atmosphere, these systems start to break down. Then on the other side, you have scientists who are looking at the whole picture. What do we need to keep the planet healthy and functioning? And on this regard, as our economic growth goes up, we're finding that one by one, the main life systems are breaking down. Literally, we only have 3 left to go before then it's like at a point where I don't think anybody can really predict what's going to happen. And I thought I'd just kind of leave you with this idea that, because I have a planted tank on my table, but this idea that, if you can just imagine that we're living in a giant aquarium, we have beautiful plants, we've got life, everything's in equilibrium, things are happy. And as you start to remove stuff, or you start to pollute it with different things, the system starts to break down. And this triggers all kinds of buffer reactions, or not buffer reactions, but all kinds of reactions which then lead to more craziness. And when that thermostat fails, you're going to have essentially fish being cooked, and life will basically die. And this is kind of like what's happening. So whilst we are thinking about net zero and those types of things, I think the narrative needs to change. The amount of carbon dioxide that we do need to remove from, globally from the atmosphere is a lot. And we won't get there unless people see removals as being a main drive and we need to accelerate this. And at the same time, keep our emissions as low as possible. But you find that most of the narrative is quite narrow in its thinking. So this idea that the life cycle approach of looking at activities in its entirety, so that we can end up with activities which will result in net carbon sinks. And another part of this concept is making sure that those results, the carbon sink, will remain for a very long time. And if you see, and like at least the last 10 or so years, people were thinking, let's plant more trees and let's see reforestation as one of those activities. And yes, it is contributing, but you can see it's 2 of 1,000 gigatons that we need to kind of address. And the other thing that we're seeing, like as you saw with the Amazon, the natural systems are no longer functioning. Or you start ending up with areas which are being burnt, and so the idea of permanence of some of these activities are starting to be questioned. So biochar is quite interesting in this space, and I think the main message that I want to get across is biochar is not the main solution, but it's part of a wider suite of ways in which we can manage land in a better way. And this is really the main message, because if we can change our approach to land management, then we are able to create carbon sinks across many different types of land use. And so that's really what this framing of this session is about. But we'll start first, I guess, with Lydiah and her experiences. So I will stop sharing my screen and pass it to her. Lydiah.
So my name is Lydiah Gatere from Kabi. And are you able to see my screen?
Yes, Lydiah, we can see your screen. If you put on
Okay.
presentation mode, that would be great. Thank you.
All right. Thank you. Thank you for confirming that. So I'll be sharing about biochar and its process, especially in the soil health and also in climate mitigation. And with climate mitigation, I most likely will just have a brief slide, but I'll concentrate on its impact on soil productivity, mostly looking at the physical, the chemical, and the biological benefits of biochar. First, let me introduce Kabi. I work for Kabi. Kabi is a non-profit intergovernmental organization established by the United Nations treaty level. It is owned by 48 member countries, which have a role in the governance and policies. And its global outreach is actually over 500 plus staff across worldwide. And actually, we're also working in Malaysia. So we address mostly on the issues of food security through research and international development. And also we are known for being a major publisher of scientific information, and especially books and academic classes and any online information resources. So mostly our areas of expertise comes in the crop health, especially in the pest and diseases, in development and communication, digital and development, invasive species, publishing, and value chains and trade. And especially that I got to know about this one through my colleague who is in value chains and trade. So getting right into the process, we'll be looking at biochar. What is biochar and how is it produced and why is it different from charcoal? So biochar is actually charcoal, which is fine-grained and produced through pyrolysis. Pyrolysis, it's heating it, or it's making of this charcoal under very high temperatures, unlike the normal charcoal that we use for cooking or as for fuel. So this biochar actually was first discovered in the Brazil, the Amazonia area, and it's known as terra preta, and it was biodated to be seen, it's over 1,000 years. And what happened is that the scientists noticed that the crops which are growing, or the plants which are growing where there is biochar, they were much healthier than the other crops or plants which are in the adjacent areas. So it has been modified, and we see that it can be done in very small scale, and it can also be done in very high scale, depending on the user or the end results. But primarily, biochar is used as a soil amendment, not for fuel. So as we see, there is a low cost and very high scale production scales. On the left side, on the left bottom side, we'll see very low scale production systems, which can be done by any farmer. And on the right side, we see high scale, and these can go into very big, costly environment. So in the low scale, we see that you can use the local kilns. Like, for instance, you can ask even a local person who does the charcoal to do for you the biochar, but under very guided scenario. So for instance, for me, when I did my biochar production in Zambia, I just asked the local charcoal producers to help me to produce it using the rice husks, and we used that as a soil amendment. But then when we go to the very high industrial one, then we need to have the one on the right, very high technology, where it uses, and it's very consistent. It is highly with precise temperatures, controlled, and there one can get very uniform biochar, unlike now the one which is low cost. But both of them equally works very well. So when we look at the physical foundations or the physical properties of biochar, we find that it helps especially in the carbon sequestration because it's very stable. When it is produced under very high temperatures, we find that it forms aromatic structures. This is structures which will attract other components in the soil to make it, and it makes it very high resistance. So it can live to 1,000 years, and it has been carbon dated several years to show that actually it is able to stay without being decomposed. It is also being used as a permanent remover of atmospheric carbon dioxide from the atmosphere. And this has actually been key, especially in the carbon credits. So it can be used for, taking the waste, and especially waste from markets, that organic waste. It can also be used for taking the organic waste from the forest or from the farm produce, so that it can now be a carbon permanent removal. So what happens is that once it's very heated at that high temperatures, it becomes very porous, and it increases the surface area of the biochar itself, in very microscopic level. So what happens is that in that high porosity, it is able to attract a lot of nutrients. It's also able to attract water. So it holds a lot of water because of that. And so it becomes very key in terms of retaining the original cellular architecture of the feedstock. And so it ends up having these micro and meso macropores, and then it helps in the different chemical and biological interactions. So in the physical capacity, then we say that it acts as a sponge in terms of attracting the water, so that it holds the water, and also it reduces any nutrients from being washed away or leaching, as we call it in the science, in the soil science. In the chemical functions, what happens is that it improves the nutrition of the soil. So what happens with that? With the pores, what happens is that it's negatively charged. So what it does is that it will attract the positively charged nutrients, so that they attached to them, and then they start exchanging those nutrients in it. So if those nutrients, most likely the soil was not that fertile, what it does is now it helps it in that functionality of being able to have those cation exchanges. And when there is that cation exchange, what happens is that now the nutrients become much more available to the plant. It has also, because of the ash that is also produced through the pyrolysis, it helps now make that soil also reduce the acidity. So the soil now becomes more alkaline. And what happens is that when we reduce the acidity of the soil, most nutrients actually become more available. And so we find that then the plants are able to to uptake those nutrients. So we find that then it also does that, what we call the buffering capacity, which is now bringing the soil to a more place where the plants are able to absorb the nutrients better. What also happens is that also it reduces the bulk density, because now we said it is highly porous, it is light. So what happens if there is compaction, then the soil loses that compatibility, and then the nutrients, the air, the water is able to pass very, very efficiently. When we go to the biological enhancement, what happens is that because of that porosity, now there is nutrient exchanges. What happens is that the microorganisms find now a very stable place for them to be able to habitat. And so what happens is that the bacteria, the fungi, and especially the ones which help with the phosphorus exchange, is that now they're able to find a place where they can now start being able to colonize and be able to have those exchanges of especially the phosphorus and all that. And what happens is that because now there's that very good and nice habitat, is that the community actually is, the microorganism community is actually boosted, and then you find that there is more soil microbial community, leading to improved nutrient cycling and better soil structure. And at the end of it all, what happens is that because now there is that very good environment in the soil structure, then you find the fertilizer dependency reduces, because now there is enhanced microbial activity, there is now enhanced nutrient availability, and that leads now more to soil fertility, which reduces the need for more synthetic chemical fertilizers. But now with more biochar application, more organic fertilizers applied, that now creates even a better place for nutrients to be much more available. So mostly to summarize about the soil productivity and what happens in the nutrients, what happens is that once we put in the biochar, it is very complicated. It has more complex structures in it, is that it improves the water holding capacity. It improves the porosity. Now that is the coming in and out of nutrients and soil and nutrients and air and water. And what happens is also now it also improves the bulk density, and therefore what happens is we reduce the leaching, that is the washing away of the nutrients, and so there is much more of nutrients which are held. And because of the biochar, because it has that high surface charge, what happens is that we increase also the capacity of the soil to be able to exchange those nutrients, and therefore there is more nutrients being available or being availed for the plants to take. And because of that, what happens is that now the plant is at liberty to uptake the nutrients in much more slow way, instead of the nutrients being washed away or the nutrients not being available. And because of it, also because of the biochar structure and the ash component into it, then the pH is increased or the pH is improved, and most of the nutrients, the major nutrients, which are usually available from 5 to around 7, then they're much more available, and the plant is able to take them at more liberty. And because of that now high surface charge, what we find is that now the microbial population increases, the diversity increases, and so the microbes are able to do what they need to do in terms of the release and the decomposition of the organic matter. And what happens is that now there is much more increase of nutrients available in the soil. And what happens is that now some of the greenhouse gases which would have been released from the soil are actually lowered in terms of their release. So in that way, then we find that, as I mentioned, that it's because of the way it functions, it suppresses the release of the potent and greenhouse gases, e.g. the nitrous oxide from the soil. And also the other thing is that now biochar is actually being recognized as a form of durable carbon dioxide removal. And there is a carbon credit which is being added into biochar because it's been seen to actively being able to work. And also, instead of burning the organic waste or putting them in the refills, we are able to convert that waste, which actually now becomes a more stable structure instead of it being released as methane into the atmosphere. I just wanted to share this graph or this diagram on the top left, showing that actually biochar is increasingly being recognized more and more in terms of the carbon credits. And we see that actually the Asia Pacific also has started recognizing it as one of the assets in terms of, voluntary carbon markets to be used, especially in the agricultural space, and that it is a technology that actually is being promoted more and more because biochar has become carbon negative. And when it's put in soil, it sequesters carbon for over 1,000 years. And I want to say thank you for listening, and I'm happy to welcome any questions. Thank you.
Thanks very much, Lydiah. I think we'll do questions maybe a little bit later, but we can jump to Niall. But that was, yeah, there's a lot to cover, and I also had questions, but I didn't realize that it also suppresses N2O emissions, which is a big greenhouse gas potential in agriculture.
Okay, shall I start, Reza?
Yes.
Can you see my slides?
Not yet.
Cool. Hold on, I'll try again. Lydiah, are you still sharing? Oh, no, hold on.
No, she's not.
Can you see my slides now?
Yes.
Okay,
just go into presentation mode.
Yeah.
And then over to you, Niall.
Okay. So I am Niall McNamara from the UK Centre for Ecology and Hydrology. We're a research institute of 600 scientists, independent and very interested in improving water, land and atmosphere through the research we do. And my focus is really on agricultural sustainability and improving that with a strong focus on greenhouse gas mitigation. And you can see a picture of one of the experiments that I have been running over the last year with biochar. But today, I don't want to talk too much about my own research. Instead, I'm going to draw on global literature to give you an idea on the trends and consensus with respect to biochar behavior in soil. And Lydiah has given an excellent kind of background and detail to some of the information I will present, but I'll give you kind of data coming from scientific publications. And I just want to start by saying biochar research has grown exponentially. 15 years ago, when we were working on biochar, there wasn't really a lot of consensus about how biochar functioned in soils. And we've gone from a handful of papers now to maybe 5,000 per year. These papers cover everything from pyrolysis technology to how biochar behaves in soil. But there's a real critical mass of activity now researching all elements of biochar science. And what we're learning from this is that not all biochar is the same, as Lydiah has said, and this can influence the behavior in soils. And in particular, the choice of feedstock, whether herbaceous or woody, can be very important. Pyrolysis temperature is a critical factor, and all of this kind of feeds into biochar structure and chemistry and how that interacts with the soil. And in terms of location, where you put your biochar is really important, and in particular with regard to soil type. So texture and pH do have a big influence on how biochar interacts with soil, and climate and management practices are also important. And for me as a scientist, we also have to think about study type. So how much biochar we apply, the method we incorporate into the soil, the duration of observations. And this is a real issue, I believe, that most of our research is in 1 to 2 year experiments, yet we're trying to extrapolate to the longer term. So there's a challenge there. And of course, whether we're in the lab, glasshouse, or field will all influence results. But saying that, there is quite a lot of strong messaging coming now. And I'm just going to run through this in terms of biochar soil interactions. So I've looked at some of the latest papers that are synthesizing data globally from hundreds to thousands of papers, and considering, the primary function of carbon capture in soils, and then the co-benefits that we're really interested in. Can we get biochar into a system and enhance the viability by delivering extra benefits to soil health and yield? And I've just kind of pulled numbers out from these big synthesis papers. The numbers themselves aren't that important. They might change if we looked at other papers, but the trends are the same. And the key one is soil carbon capture. And we see a large increase in carbon in soils as a result of adding the biochar carbon itself. But biochar can also stabilize existing organic matter or carbon, adding another sequestration pathway. And as has been discussed, nitrous oxide derived from fertilizer is a potent greenhouse gas globally. And this is a big area of research for me in terms of biochar. And we see nearly in every experiment a 30 to 40% reduction. So if we think about this in terms of combining the soil carbon capture with the nitrous oxide reduction, this is a very valid approach to reducing the greenhouse gas intensity of farming at the field scale. And we also have other benefits. Adding biochar to soil reduces the density, it increases porosity, root ingress, and essentially helps soil moisture dynamics. And what we see from a lot of work is potential for biochar to buffer against drought, for example. So overall, the physical structure can be improved. And it has been said, soil pH can rise with adding biochar because it's alkaline. And this frees up existing nutrients in soil to become more plant available. And some nutrients can actually be released from the biochar itself in the short term. So what we're seeing here is a picture of multiple soil health benefits. And the question is, how does this translate to yield? So looking at other global synthesis studies, what we're seeing are yield responses of 10 to 16% on average. So these are modest, but they're still very important. And individual studies have bigger ranges, but there are some big caveats. And just drawing on a paper by Jeffrey, they have highlighted that lower pH soils are the most responsive in terms of yield. And in general, low pH soils that are degraded will kind of respond to multiple benefits of biochar addition. And to an extent, this contributes to the fact that this paper reports that tropical yields are much better than temperate yields. And this is what I've seen in my own research in the UK, where I've never seen a yield benefit with biochar, but other studies in the UK are suggesting there might be some. A more recent review has highlighted that if you combine fertilizer, this can be inorganic or organic, with biochar, you can actually get the best yield responses. And that kind of helps tip things towards temperate zones, but it's still best in the tropics in terms of overall responses. I just thought I'd give a little case study of some work we did in Malaysia with an organization called Crops for the Future. And we were trying to just do a little demonstration project about how biochar could be integrated into smallholder agriculture. So we took a fodder crop called Lucena that grows in the wild and everywhere in Malaysia. This is peninsular. And we used a simple biochar retort. So this is low technology, could be deployed in community setting, and converted it into biochar. And we applied this to 3 different soil types of different acidities and integrated that into a simple pot experiment with a salad crop Amaranthus. And the results overall chime very well with global studies. So we found a 17 to 54% increase in yield, but only in the most acidic, nutrient-poor soil. So the other 2 soils, we did not see that yield response. And in the absence of fertilizer, the biochar yield benefits were small. So I think there is a case to thinking about adding inorganic, organic fertilizer with biochar, but maybe we can reduce that. And just kind of in the Malaysian context, this is some work I'm doing with Reza at the moment, where we're trying to see if we can reinvigorate smallholder oil palm plantations through biochar incorporation. And our logic is clear that these soils can often be quite degraded, so there's good opportunity to bring biochar in. And there's a huge range of potential feedstocks that we can add value to and actually have an overall kind of more circular approach. So at the moment, we don't have data, but we've got a 10 plantation trial in Malaysia where we're looking at nutrient dynamics, water infiltration, microbial diversity, and greenhouse gas mitigation. So hopefully we'll be able to report on that in a year or so. So just my key points are generally, the literature is suggesting good soil health and climate mitigation benefits from biochar from a range of published literature over the years. But we need to be aware that those benefits are not universally observed, with best yield outcomes and responses to biochar in low carbon soils that are degraded. There's a critical need for long-term studies that really follow the behavior of biochar over long-term times. This is looking at benefits, but also risks. And from what I can see, there's very limited research on oil palm plantations and soil biochar functioning. There's a lot of information on pyrolysis, but I think there's a research gap in terms of field-based research. And that is my contribution. Thank you.
Very good, Niles. Niall, yeah, I think we're sort of running late on time. I see some questions in the chat. I think there was one question around, why gasification, why you're so focused on agriculture. And I think it just so happens that I picked two speakers who are focused on agriculture and biochar. But the next session, we're going to have a speaker from Taiwan, and they're really looking at the other applications beyond agriculture. I don't see any other questions coming through. Lydiah or Niels, is there anything you guys want to add? If not, we'll move on to the next section. And I
mean, just on the agriculture side, I guess biochar is something that can be integrated into existing practices, and it obviously delivers these additional co-benefits. And that's why there's a lot of interest in using biochar in agriculture.
And Reza, there's a very quick question from Simeon Max. I think maybe just if there's an opportunity for us to address that before we move to the next session, if that's possible. Reza?
Yeah, I can. I don't know. Yeah, maybe the next at the end of the next session.
Sure.
So let me just go through. I'll move on. How do I do this? 2 seconds. So, I'm starting to see that, even just the first session, we could spend 2 hours on this or more. I didn't realize that there's actually quite a high number of research being done, around the world on the biochar application, et cetera. But I kind of wanted to bring it home in the sense that what we have been seeing is that when you look at a lot of soil under industrial agriculture today, and this is after many years of fertilizer use or other ways of land use, you find that the soils are becoming more compacted over time. And I think that, I didn't appreciate just how much biology played in creating better soil health. And as we saw with the first, especially with what Lydiah was kind of showing, was the role that biochar plays in terms of aggregating or attracting nutrients, water, and how this becomes the building blocks for a lot of the biology to form. So prior to using biochar, we also, sort of ended up in the same place, but really kind of focusing a bit more on how do you stimulate that soil biology with organic matter? How do you stimulate soil biology with different types of ferments? Because we were thinking very much around what can a small farmer do, but don't be hung up about the fact that this is smallholders, because I'm starting to find out a bit more that the ferments are working because you are encouraging bacteria and fungi that have adapted to life when there was very little oxygen in the world. And so this idea that these microbes are the building blocks of all life on the planet, this is partly the reason why thinking about how to enhance soil biology or the biology in agriculture is actually the big theme which some people are starting to unlock. But we've seen it for ourselves in terms of the smallholder blocks. We have started to think about this as farming networks with a hub in the center of this. And this is where, I think somebody mentioned in the chat group, I've seen people doing it in an open pit. So people have studied that actually it does produce biochar in an open pit or sometimes even a closed pit. And this method, which is the Kontiki kiln, is something that we've used. And there has been different researchers looking at, why this works and does it get to the right temperature? And temperature is really one of the key factors behind how to produce good biochar. And I think Peter will talk about this in the next session, because he's looking at this as if you want high grade biochar, you've got to control these factors, which you can't do so much at the sort of artisanal way, but at least it gets you good quality biochar. And the other reason why we know this is because we've gone through the process of certification. So we follow the rules. I think the other thing that Lydiah mentioned, that the porosity of biochar is high. And you can see here with the electron microscope that this is the reason why this happens. There's just so many little micropores. And then to Niall's point about biochar alone isn't the magic bullet. Biochar needs to be combined with biology. And in our case, what we've done is we've created compost, which is the mix. And this is what goes out to the field. So the results are still relatively new. And it's because this is one management method in a suite of management methods to increase soil biology within the farming communities. It's very hard to say that it's biochar alone or it's something, some of the other things that we're doing. But we are, so at least some of these trials are starting to happen. I mentioned before that, we're pushing ahead with making sure that everything we do is validated. So we have undergone the process. We also know that, these activities that we are doing, when you look at this from a life cycle approach, we're also seeing that you can demonstrate that overall your farm emissions will be significantly lower. And this is the part which I get excited, like this idea that the farms themselves can be not just a source of new products, but it's also then the biomass which can then feed into sort of pyrolysis process and then to come back into the farm itself. The other factor with trees in oil palm blocks is the fact that fungi love lignin. So if you have a lot of different sources of lignin in your farms, you will end up with a much more diverse fungal diversity, and they are the key behind extracting these morsels of food, which is then delivered to the plants. So finally, on just in terms of so apart from just the carbon measurements, we started looking at and Eduard will talk about this later, just about the ecosystem changes at the farm level with these new practices. So we're seeing, for example, in conventional plots, you're more or less always on the emission range, compared to the bioblocks, which are strongly on the sequestration range. But also interestingly, like it's not the same in every year, but at least the net result ends up where you want to be. So I think like they give us, you know, almost like two dimensions in terms of how we could design opportunities for you know, incentivizing change at that fundamental level, land use. And then I also was, you know, I was just sort of thinking, you know, depending on the different methods, if we take it up to, you know, if we can cover 1 million hectares, how much of an impact we can basically have. But basically what you see is that, you know, palm as a global industrial crop has a sizable potential in terms of delivering real impact at an ecosystem as well as at a very local level. So this is partly the one reason why, which is why I think this is quite important. And then number two is then, you know, once we figure this out, taking it to other industries, looking at how new investments can come in. This is partly the reason why, you know, at least for me and others, we're sort of very much focused on the land application side. Now, on the other side of the fence, you've got very large players talking about doing the same thing, carbon reduction or carbon removals, but with very crazy technology. And on a per ton basis is actually quite high. But people are excited because folks like Microsoft and others are on the buying spree right now. But I just want to put this into perspective that, you know, we could achieve the same thing in palm and do so much good versus a large factory trying to suck up carbon dioxide and pump that back into the soils. So had to say that. So what I've kind of shown is the artisanal. We're going to jump now to the tech side of things, I mean, or the higher tech side of things. And all technical questions, it's best directed to Peter because he's the man. So Peter, over to you.
Yes, I hear you. Okay. Can you hear me?
Yes.
Okay, so how many time I can presentation?
5 minutes would be best, but let's see how.
Okay, okay. I will finish in the 5 minutes. Okay, and so who is in the control the presentation?
You.
Me?
No
Really?
worries, I am. Yeah, you
Oh,
can
you
shoot
are.
me
Oh.
when you want to next the slide. Thanks.
Okay, okay, okay. So I said the next page or the present turn to next page. Okay, I will finish in the 5 minutes. Can start. My name is Peter. I'm from the Taiwan. Our company is TCHAR. So we are producing the biochar. So I think before a lot of the people just talking to the biochar, the function, the methodology. So I just focus on the biochar the application in the Taiwan. Okay, next page. We are following the biochar regulation because I think the biochar the value is to the IPCC in the Article 6. So just very clear to identify the carbon removal, the methodology. The biochar is one is an important method. So we just start to the development and the biochar, how to produce the biochar for the material. Next one. Our company is my background is a civil engineer. So we have over 20 years just in the service to the chemical plant. So the mission is to solve the climate, the customer and the problem. So in a chemical plant, we have a lot of complicated the problem. Want to provide a solution. So we just have find a lot of the project. So like for the working at high, and we just replacement some oil boiler, and we are working underwater, and we have some emergency and response. So some oil spill, we just want to try to find a solution and solve the customer the problem. Next one. So in the right now our major client in the Taiwan is Formosa and the plastic group. So it's the biggest chemical area in the Taiwan. So in the inside we just from the 2006 I have another company is a synergy composite technique. So we just use a lot of special material to solve the client, the customer there and the problem. So we have a very good material and the background. Then in this moment, we find another new application for the pyrolysis system. So this pyrolysis system can produce the biochar. Then the biochar is a very good material. So we have another one company in 2020, and the TCHAR was found. So we just start the installation. The first one equipment is the Pirate from Germany. So right now this equipment we are already running over 1 year. Next one. And so we are 100% follow the CSI standard. So right now we produce the biochar is just get an EPC the certificate, and we just use an EPC certificate the product and try to use an biochar to the material. Next one. Until this month, we just have an EPC and certificate and license in 1 year. Next year we will try to go to an inspection from the next month. So we will get another EPC because the EPC certificate is each 1 year. We want to recheck and get. So now we have this certificate, and our carbon sink is a 1 ton biochar. We can remove all the 2.625 tons the carbon dioxide. Yeah, so that's our number. Next one. For the biomass is very important. So our biomass on all for the tree and for another like a bamboo. But all the biomass we just want to follow an FSC. So we could just got a FSC certification to keep our biomass is a high quality fit for the EPC and the standard. Next. Next page. Yeah. Okay. This is our equipment, and it's 100% from the Germany, because right now we just want to first one equipment is totally can fit for any standard. So we just improve this system, and this first equipment we can produce the biochar 1 ton of biochar. So the annual year we can produce 240 tons of biochar 1 year, and from the next year we have another two largest machine will be arriving in Taiwan. So in 1 day we can produce the two can over 7 tons of biochar 1 day. Next one. Next. Okay, and so our biochar the certificate from the EPC. Then we want to go the carbon sink. So our carbon sink and just working with the cooler. So our all the DNRV is from the using the cooler and service. So we just have the first time the carbon sink from the last month. Next. Okay, so our process is just from right now the business model is just from the waste wood or any green waste and into our pyrolysis system. So we can get the fit for the EBC standard biochar. So our biochar now and the application development in the biochar plastic and the biochar concrete and the painting and the cosmetic. This is our application right now, and we are just working in Taiwan. Our partner start to the development for this one, and this one also we can get the EBC in the global C-Sync the label. So using this label the product, we can help our client to stick in there the product, so they can help them and the products have a much more high value. Next one. So right now in our biochar application just for the fertilizer and I think for the agriculture and a lot of people and working for this one. So right now in the TCHAR we are just very focused for the material. So from the food and the construction and the electric and the cosmetic, and right now we have another special application focus on the water and the treatment, because now in the PFAS, the pollution is very serious in the world. So we have another project with the university, try to application the biochar to solve the PFAS and the problem. Next. Our major for the application for the plastic and the carbon fiber and the coating and the construction material. Also right now we have a ladder. So right now the ladder is in the last week we just success and development this and the product. Next page. This and is we have help our treadmill the company. They use the biochar plastic add in there and treadmill all the plastic part. So this one is in the Coulomb fiber. So this time we can announce the first and the CO2 removal and the treadmill. And this is the machine is show on the fiber. So you see the picture and two gentlemen is one is an EBC, the CEO Willie and I think the Michael, yeah, is go to and visiting and our supplier, the partner, and the cities and the treadmill. Next one. This is we also we try to use biochar to the 3D printing. Then we are successful and use put the biochar into the 3D printing line, so we can making a lot of small piece that produced. Next one. So we have this from this page is our newest product. So our product to any like for the transportation and a lot of plastic and product we can just selling to our customer. Next one. This one is another application. We use biochar with concrete. So we use the 3D printing. So this we use the part. This part looking like the Taiwan. So we are also selling to this solution. Next one. Have a 3D printing because we can play for this one, and all the video we will put out in the company and the website later. So if everybody is interested, and can go to our company website to see the video. Next one. Another one is special is for the cosmetic, because our company have another our CSO CKO is Yuan, so it's interesting for the cosmetic. So we have another for the cosmetic application for this one, because the biochar is a very clean and a very natural good material. So for the cosmetic, it's a very good. We can replacement for the carbon black. Okay, next one. So we are the first time the carbon sink to the soil. We just finish in the city Taichung and the Science Park, and this is our picture. Okay, next one. This one is we have for the ocean and marine and biodiversity. So we just we use the biochar into the concrete and put into the ocean to the coral brick. And this one we are same time we are finished for this application. Okay. Next. Yeah. Okay. That's we have a lot of exercise. Next one. Okay.
Yeah,
Thank you,
good.
everybody.
Is that you, Peter? The Superman.
Over 5 minutes.
Yeah, over 5 minutes. But anyway, look, there's some questions which I can't answer in the chat. So hang in there, because maybe we could kind of answer. There's a technical thing, because I know biochar can be produced from gasification and pyrolysis. But why one or the other? Because yeah. So why pyrolysis versus gasification?
Okay. Because for the economy, because we are a company, we want to earn money by ourselves. So we need a high percentage of the biochar. So using the pyrolysis, we are only can get the biochar and the syngas. So we have the syngas to a renewable energy, and we can get the biochar for the maximum. In the gasification is a recent application, just focus on to the renewable energy. So it's a different application. It depends. Depends on the
I see. So gasification, people invest in this because energy is the main usage, whereas pyrolysis has a slightly wider application. Okay. And then
pyrolysis, yes.
Yeah. So then the other question was, there's quite a few on heavy metals, because so just for example, like when you put biochar in eco-bricks in the sea, is it aggregating heavy metals or microplastics? Or when we apply biochar in soils, is this also happening? Do you have an answer, or Niels, do you have an answer?
Yeah, Reza, I mean, biochar has a high surface area and it can absorb heavy metals is the answer. So in our field trials, we would normally see a reduction in heavy metals in the soil as the biochar absorbs some of the metals.
But does that mean it's accumulating over time?
I think to an extent. I mean, at some stage, the biochar might become saturated. It's not something I know a great deal about, so I should be careful in how I answer it. But we do see a reduction in metals in the soil due to biochar absorption.
Do you want to say something on the other scary thing that we've been doing together, looking at heavy metals in soils? The high levels of sediment. No, for Niall.
Which work is this?
Well, the one we did in Sabah.
Okay, so in Sabah, we've done soil surveys trying to look at soil health in terms of carbon stocks and metals. And we have found in some locations very high metal pollution. And we think that is associated with kind of fertilizer products that have metals in them. So we haven't taken the work any further, but we have just identified some areas that are real hotspots.
Yeah. So fertilizer use is is adding heavy metals into soil.
Yes, there are some metals.
Yeah. So biochar could have one application there. I think that just the one final thing was on, is there a chance that if the biomass itself has high heavy metal content, say, for example, if it's from a waste stream, when you produce biochar, what happens to that I mean,
a lot of the metals will become concentrated in the biochar, but that's why there's EBC certification. So, you know, the feedstocks should be assessed before they go into the pyrolysis system. That's part of the risk assessment, that you actually do that initial analysis of the product.
Okay. Yeah. So I think this is the message, really. Like, you know, I've also seen in the chat group, people are saying, oh, you know, we can do biochar in a pit, we can do it in artisanals, et cetera, et cetera. The main thing is that if you don't know what you're doing, it can go horribly wrong. So partly this certification framework is a way forward in terms of, you know, pick a feedstock, pick a process, and have that certified, because then that gives you the, you know, what would be your guardrail, so to speak. And I think that kind of leads us quite nicely to the next section. Thanks, Peter. Thanks, Niall. Which will be the sort of validation end of the spectrum. So we've got Luki, I think, presenting first.
Yeah. Hello, everyone. My name is Luki, and I'm from Carbon Standard International. And I will share my screen. I have no idea how to share my screen. Oh, sorry. Can you see my screen?
Yep.
Yes.
Yeah.
Okay. Thank you so much for everyone that organizing this event, this online event, and for the participants. Welcome. Yeah, I will explain a little bit about biochar in voluntary carbon market and our role as a standard developer and manager. So this is a little bit about biochar in voluntary carbon market. So the average price of biochar credit out there based on CDR.FYI is $150 in average. And it of course depends on the type of standard, the type of technology, etc. And biochar is a high integrity carbon removal credit with tangible co-benefits, as explained before by previous presenter. It has a lot of benefits in agriculture, some materials, cosmetics. So there are a lot of other benefits. And then the permanence is 1,000 years when H2C ratio is more than 0.40 and applied in the soil, and 75% PAC treated as geological sink based on EBC, WBC standard. And it also has international recognition out there with ICVCM, ICROA, and others. And this is a biochar standard throughout the year. So it was first developed by Ithaca Institute. It was European Biochar Certificate, where it used to evaluate the quality of the biochar. And in 2021, EPC CSING Guidelines version 2.1 released to certify carbon sink and potential of biochar. And in 2021, Carbon Standard International worked together with Ithaca Institute and become the standard owner. And together we releases more standards with Ithaca, like Global Artisan for smallholder farmers, World Biochar Standard, Global Construction, Global Tree Ceasing, etc. And Puro developed the first version of the Puro biochar methodology in 2019, and they released an update in 2022 and 2025. And then followed by Vera in 2024, where they 23, where they released the biochar utilization in soil and non-soil application version 2.1.2 with VM 0044. And then the latest is isometric, where they released biochar production and storage in 2024. this list might not be updated properly, so I apologize in advance if it's not the updating. And We Carbon Standard International is an organization that manages standard certification and registry system in the carbon removal or biochar and carbon sink space. And we have a few services. First is biochar quality with European biochar certification and World Biochar certification. And in this biochar quality itself, we assess whether biochar fits into the WBC Agro or EBC Agro, EBC Fit, Agro Organic, Urban Materials, etc. So there are a lot of qualification and in the certification. And all of our client always go through in EBC or WBC what we call technical pre-audit, where they assess, do due diligence in their project, check their feedstock, check their system, everything, the calculation in the technical pre-audit. And in the Global Artisan Ceasing Standard, which is the standard for smallholder farmers, what we called is endorsement phase. So where we assess their feedstock, their location, their sustainability of the feedstock, methane emission, everything is evaluated there. And to issue the ceasing, we have a standard called Carbon Sink Standard, which are Global Artisan Ceasing Standard that focuses on smallholder farmers in low to middle income countries. And second one is Global Biochar Ceasing Standards for the industrial size biochar production. And third one is Global Tree Ceasing Standard for tree planting projects. And the latest one is Global Construction Ceasing Standard for buildings. And we also have online tools, which is Methane Calculator, Global Ceasing Tools, Biochar Tools, and World Climate Farm Tools. And so far, carbon standards have issued more than 500,000 tons of CO2 equivalent in our global ceasing registry, and 77% of it comes from Global Artisan Ceasing Standard. And we grow together with partners, as you see on the previous slide, that we are the first standard owner for biochar. So we always tackle the problem together with the client. We always open to new feedbacks, to discussion, to grow together with our partners. And our standards is inclusive from big industry to smallholder farmers. So we have both global artisan to manage the smallholder farmers and biochar ceasing standard in combination with European biochar certification or WBC for the big industry. And we are the biggest ceasing issued in biochar so far. Let's keep it that way. And this is some of our project in the Global Artisan Standard. We have Carboneers in Ghana and India. They're operating with smallholder farmers. And we also have Faraha in India and Biochar Life in Thailand, Kenya, Malawi, and Indonesia. So they're, I think, the biggest tree producers that we have at the moment. And we're really proud of them that we grow together and develop projects together. And this is the Global Artisan Ceasing Standard in Malaysia. We have Wild Asia. We work together with Reza to have their project in the Global Artisan Ceasing Standard. And it is now have been validated, and it's utilized the palm oil front and palm oil waste. And I want to be clear here that we do not accept all kind of palm oil waste. We always do due diligence very carefully because palm oil is quite a sensitive topic for credits out there. So we are really assessing it properly. And Wild Asia passed that, and they are becoming, I think, the first artisan ceasing in Malaysia. And I think this is a very good opportunity for any other project developer in Malaysia that wants to work together with carbon standards. We have two separate standards, one with smallholder. If you work with smallholder farmers, I think the potential of feedstock in Malaysia is huge. I think like rice, corn, everything that could go under the artisan. And if you are a big industrial player, big industrial with the big pyrolysis system like TCHAR, then you are more than welcome to work with us with the global biochar standard in combination with World Biochar Certificate. And a carbon standard is fully endorsed by ICROA, and we are in the process of getting endorsement by ICVCM as well. So this also to increase the trust in the market in our standards. And yeah, I think that's it from me. Thank you so much. If you have any question, feel free to ask.
Thanks, Luki. I think you can ask in the chat. Thanks very much for that. So then we're sort of kind of taking it beyond just biochar and coming in with carbon spaces work. So over to you, Eduard.
Okay, so thank you so much, Reza. I think you can see my screen now. And
yes.
Hi, everybody. Nice to be here. What I would like to do today is to zoom out a little bit. I've spent quite a few years on biochar in the artisan context in the past years, and at the same time also at the natural-based solutions, so in forestry, agricultural, carbon project development. So basically the nexus between biochar application, at the same time also the impacts on land use. So what I would like to do today from a carbon space point of view, explain a little bit how it can work in terms of measurement, reporting, verification of biochar application and beyond. But at the same time, I would like to zoom out a little bit from specifically only biochar, but also looking at a bit at the market developments. And I think this is specifically interesting and relevant from a corporate or company point of view, especially the oil palm mill sector in Malaysian context is probably very relevant of what I'm presenting. Because what we can see in the past 5 years mostly is related to the Science-Based Target Initiative. The Science-Based Target Initiative is a voluntary kind of initiative setting standards for the global corporate sector to decarbonize across the whole supply chains, across the whole kind of company level impact. And what we've seen in the past is a huge jump and increase of companies globally to commit to this SBTi targets, science-based targets, to become either net zero or to drastically reduce their emissions in the next 20 to 30 years. So a huge trend. What does this mean from a company point of view is, so I mentioned the corporate net zero standard, SBTi, and then companies that are operating a lot in the agricultural forestry space, they have so-called forest, land, and agricultural science-based targets. They have to set them if they commit to this SBTi standard. And that means that they will have to first understand their emissions portfolio and the inventory, and then at the same time also identify measures to actually reduce greenhouse gas emissions and removals in their supply chains. The way it is set up, it's still an evolving kind of mechanisms. So the SBTi basically sets the standards on what to do. But then the big question is how to measure all this. So how the corporate sector is able to measure the greenhouse gas impact and removals across the supply chain. And this is where the land sector removal guidance comes into place. Many companies already apply part of the GHG protocol for other compliance purposes, but specifically for SBTi, this land sector removal guidance will be the key framework on how to measure, how to report on emissions and removals across the supply chains. It means if companies, for example, apply biochar, it's also covered by this guidance. At the same time, if you have certain emissions on the plantation side, it also needs to be covered. So it's much more holistic than just one specific intervention like biochar. And why is it important? It's important because it is the foundation and the basis not only for the SBTi, but also if companies want to do insetting, if companies want to export to the European Union, this guidance has a high relevance for companies. Let's quickly unpack what this GHG protocol land sector removal guidance is before we jump into the biochar application specifically. So what is so relevant and important about this land sector removal guidance is it requires primary data-driven approaches. So which means companies who do greenhouse gas inventories report within this framework will have to collect some primary data to verify what they're reporting, the data, the emission, the kind of the default value approaches and so on need to be verified to make sure that it's actually field verified. At the same time, it requires companies not focus on only one specific, let's say, carbon pool, like let's say trees, above ground biomass and below ground biomass, but really look at the whole spectrum of carbon pools, which is above ground, below ground, soil organic carbon. And if you, some or many of you are probably familiar how challenging and difficult it is to measure to do individual carbon pool monitoring and accounting. Because for trees, for example, you need to go and measure the tree height and the dBH diameters. For soil carbon, you need to go to do soil sampling. And it's obviously that it's quite expensive and quite a lot of effort to do this. At the same time, there's also a requirement for ongoing monitoring. So if you have a land asset within your organizational kind of boundary, and you account as an organization, you account for carbon removals, there's also a need to continuously monitor this impact that you are claiming. A lot of strict uncertainty requirements. And I think what is also very important, because we are working, or companies work across, not in isolation, but in partnerships and with different supply chain partners. The data interoperability is really a critical element where we can connect the impacts between different companies. So let's quickly go into what this actually means from a biochar application point of view, and what can be the solutions there. So let's assume we have a wildflower plantation and biochar is applied. So what we've seen so far and what we've discussed today was mostly about biochar gets applied and you quantify how much carbon is within the product itself. But at the same time, we've also seen that once you apply biochar, there is an incremental or positive impact on the ecosystem itself. So we can expect roughly, I've looked up a little bit the scientific evidence. So we can expect that there is above ground, below ground biomass increase by better growth performance. It can also trigger soil organic carbon increase. And obviously it also has higher crop yields. So the big question is, how are we going to capture the incremental, the additional growth of the ecosystem, so the ecosystem responds to biochar? Because today all the methodologies and the carbon market doesn't actually not provide for a system where we can combine biochar carbon as a product combined with ecosystem response, which is also a positive incremental impact. So that's where we from Carbon Space can actually be useful, because what Carbon Space does is basically monitoring net ecosystem exchange. So it goes away from this traditional accounting approach of measuring individual carbon pools but rather measuring the fluxes, the carbon fluxes between the atmosphere and between the ecosystem. And that enables also to account for all carbon pools, not only one specific, which is quite much more efficient if you can actually capture the benefit and measure the benefit of the whole ecosystem rather than individual carbons. It has a big advantage that it's lower uncertainties. It is also much more efficient if you have one measurement for the whole ecosystem rather than a lot of different measurement systems for soil, above ground, and so on. And it's also more consistent. So how does it work? So what we've started doing over the past 5 years is using the 40 years old technology called eddy covariance ground stations. So these eddy covariance ground stations are basically carbon flux measurement devices. The science has used it now, I think, for about 30, 40 years to understand what is the carbon fluxes between the ecosystem and between the atmosphere. So it's the most direct way of measuring carbon according to what we have today. But at the same time, you can imagine it's impossible to put all these ground stations everywhere. So we need to find a way on how we can use the data from the ground station and replicate across the whole landscape. And that's where the remote sensing comes into play. That's where weather, climate, meteorological data comes into play, and machine learning. And basically what we can do is then, by combining all these different data sets, we can actually go to individual polygon level and measure how much carbon has been sequestered or emitted throughout on a specific polygon over 1 year or even over 1 month. So I think this is quite a new, unique approach on how to monitor in a more efficient and effective way. And that's probably going to be, we believe that in future, this approach will become a much more standard, because carbon standards, if you look at the industry, it remains a relatively novel new approach, and only very few are still in this process to really understand how this technology works and what are the opportunities of this one. So I take this opportunity also here to create a bit of awareness on this technology and how it works. And my last slide for today. So basically, in summary, I would like to say that, I mean, the SBTi flagged the GHG protocol will and are becoming the key standard and regulation for, especially for the corporate sector, where they will need to commit to science-based targets and also do greenhouse gas inventory and account for it. Then in terms of biochar, what I think is the big weakness at the moment we have is that most of the carbon standards and systems do not measure the net ecosystem impact of biochar application, which I think has really a lot of positive benefits, but we have to measure it. And to account for the land-based carbon removal impacts, I think the individual carbon pool accounting will be quite a challenging thing in future, especially if you look at how many how many hectares a corporate company, let's say an oil company, has. Doing primary data collection at 100,000 or 50,000 hectares of land is a really extremely challenging and expensive task. And therefore, we believe that the flux-based approach, doing net ecosystem exchange, is probably a game changer for the industry to make MRV, monitoring, reporting, verification, scalable, low cost, and much more accurate than we have today. Thanks.
Yeah, very good. Jenifer, do we have to have this hard stop, or do we have a little bit of time?
Yeah, I think maybe we can go for 5, maximum 10 minutes, Reza, because I think because it's we would probably need to let people go, and so, but I think there's a lot of people who's very interested in the topic and probably keen on some of the questions and answer as well, Reza. So let's go for tops 10 minutes here. Thank you.
Yeah, so maybe I just apologies for not being able to answer all the questions. I just noticed the box. I was getting it in another box and I realized I was in the wrong place.
Yeah, you were replying to the panel, the host. I think.
Yeah, exactly.
But
anyway,
yeah.
But as panelists, you know, there is a little box at the bottom which says Q&A. So I think as we open up to the floor, if there's anything that you can answer along the way, I think that would be helpful. I think you know, in terms of just like taking a step back and pausing, I guess what I'm, you know, this topic is quite complex. On the one side, you've got companies who have products from the region. So there's reporting that's kind of happening. Then you've got people who are actually working at the farm level, I can see from the audience. And then you've got some different types of producers. So there's quite a range of people around this room. But I guess we just have simply no time to get into everything. But anyway, 2 to 3 burning questions, or even just things that have popped out from the group panelists and the speakers in terms of, you know, what you see as the big gap that needs to be filled in if you want to see some change in terms of not just biochar adoption, but, you know, sort of land use change for the better. Anyone?
Maybe I could start just to kick out the discussion off. No, I think what is really important, I mean, biochar is a relatively new, not yet commodity, but a technology to remove carbon, but at the same time, I talk from an agricultural point of view. I think from an agricultural point of view, it's a really, I've seen in Africa in doing and leading projects, it does really magic in terms of yield improvement, in terms of soil health and so on. So, but I think what we also still don't understand from a scientific point of view is how to apply biochar in the correct way. Yeah, because there are many different trials, but I think giving proper recommendations to a specific context, wherever you are, it remains a challenge. And I think you are doing a great job with Wild Asia, with the scientific approach to really test things out. I think it's a very critical element to do. But at the same time, also, I mean, I'm talking more from the monitoring, reporting, verification point of view. I think the measurement approaches, not only at biochar as a product itself, because that's relatively solved. There are good methodologies, that's good. But what is really missing is what is the impact of biochar application long-term on soil health, on carbon sequestration, carbon removal impact. I think that remains still a very large open question and requires quite a bit of work. So I think this would be, yeah, my key points from this discussion today and from the learnings we've had today here.
Yeah, thanks for that. Niall, are you still there? Because there's questions around biochar and all these applications in tropical soil. So is it all just dominated by Western research? But I think I do remember that your slide said
no. In fact, where the real growth in biochar research is from China. I mean, there's quite a few Chinese soil scientists doing work in many areas, but that's one of the areas where there's been outgrowth. So it's not just temperate zones. There's a bit more balance now. Yeah.
And in terms of biochar in tropical soils?
In terms of, yeah, I think so. I haven't looked in detail, to be honest, but I have noted that there's quite a large amount of literature coming from China now.
Okay, good. Yeah, then I think someone was asking about, you know, because you're going to have different standards being applied for removals, for carbon projects, etc. So as Malaysia sort of develops a carbon market, how does one ensure there's no double selling and stuff, or so like what's the missing things in terms of making these registries more credible so that these things can be claimed at a national level? Maybe that's probably more for you, Eduard.
Yeah, and I think the double counting issue is pretty important. I mean, the Article 6 frameworks are evolving, and I think that's the role of the governments to make sure that there's an enabling environment for carbon projects. But at the same time, because I mean, what I've seen a lot in many other countries is also the double counting issue. So, for example, if the national determined contribution, the host country claims the carbon benefit from a certain activity, and at the same time, a company who invests in a carbon project, they're also claiming and selling the carbon credit. So, making sure there is a framework where the government and then the system allows a private sector investment into the technology and claim the benefit without having a reputational risk, I think is quite important. At the same time, also we see what I mentioned on the SBTi, it's still voluntary, but corporates also are committing to net zero targets, which is outside of the governmental system, but at the same time, companies also claim that they have a net or reduction in their inventories, which is at the same time also the NDC targets or NDC commitments, because everything that's in one country goes into NDC, but at the same time companies operate not in isolation, but in specific countries. So how do we make sure that we don't have these double claims between the systems in which we operate? And that's quite a big task, I think, in any country to find this system, this regulation that enables actually private sector to decarbonize, rather than punishing them and putting them a lot of restriction in what can be claimed, what can be sold, what cannot be sold. So I think this is really an important policy-making activity.
Yeah, and I think what I've seen is like there's a shift towards kind of more in-setting scenarios where people are looking at products and claiming it within the product rather than claiming it in a sort of offset manner. So I think the work that Peter's doing which is accounting for that carbon in a product, creating a product which then has this low carbon value, I think is one direction. I think the other direction I've seen is also with, for example, like palm oil, people are also thinking around that space. But probably the most relevant is the fact that there's still questions around, is biochar going to work? How do you know that you've got quality biochar? How do you know whether your application is then a positive thing or not? So there's actually quite a lot of framing around quality control that, so certification may cover how you produce and your feedstock is okay. It doesn't really cover you when you're applying it in the field. So I think that's, there's still a space for, literally carbon space. I think there's definitely a space for something like that. But there's also spaces for other ways of monitoring soil health, plant health in relation to these activities. But I think we're going to have to kind of call it a day. I mean, just to say that, I mean, from Wild Asia's side, yeah, it's been really good that, all the speakers have been willing to participate. I just didn't realize that maybe it was just too many things to talk about. But there will be a summit on November the 2nd in KL. So if anybody is physically available, there's another version of this, but this time with more practical applications. And we've got some people from finance and the supply chain end of things who are giving their perspectives on how they're making some of these things happen. Okay. All right. So over to you, Jenifer.
Reza.
Thanks very much, everybody.
Reza and everyone, thank you so much for, all of the participation and also the audience for the engagement, right? As you said, Reza, I think we could go on for another hour or two on this, because I think the I think just to echo what you said, that the science is quite advanced, right? But there remains questions around execution, practicality, accounting, and certification, and all that, and that's part of the journey. But I would like to take the opportunity to thank Wild Asia. Thank you, Reza, for curating the session today. Also to PwC Malaysia for capturing the key takeaways and the list of questions that we still need to continue to address. And as I mentioned earlier when we started, this is the first of the 18 roundtables that will take place across the next few weeks. So I hope audience, please sign up for the sessions that you're interested in, and I hope that we'll carry this momentum forward. So thank you again. There's a survey that should be on your screen now. So please help us to complete that, and that will help us as we carry on to our next session. So Reza and rest of the speakers, thank you very much. We'll see you soon again. Thank you.